What if the first proof of alien life isn't a flying saucer or a radio message from deep space, but a color? Specifically, the color purple. Right now, scientists are developing brand new methods to hunt for extraterrestrial life. And some of these approaches are so clever that they could completely rewrite what we think we know about biology beyond Earth. We're not talking about decades from now. We're talking about telescopes being built right now, techniques being tested right now, and a generation of researchers who believe they might be the ones to finally answer the biggest question humanity has ever asked. Are we alone? Stick with me, because by the end of this video, you'll understand exactly why the next 10 to 15 years could change everything. Let's start with the numbers. NASA has now confirmed over 6,000 exoplanets. That's planets orbiting stars other than our Sun, with more than 8,000 additional candidates waiting to be verified. And scientists estimate there are billions more just in our galaxy alone. But here's the catch. Finding a planet is one thing. Figuring out whether anything is alive on it, that's a completely different challenge. Even the closest known exoplanet, Proxima Centauri b, is more than 4 light-years away, roughly 24 trillion miles. You can't exactly send a rover. So scientists have gotten creative. And one of the most surprising ideas comes from Lisa Kaltenegger, an astrophysicist at Cornell University. Her argument is that we've been too focused on looking for green, Earth-like worlds. Most stars in our universe aren't big yellow stars like our Sun. They're smaller, cooler, and redder. If life evolved on a planet bathed in red starlight, it probably wouldn't use chlorophyll the way plants do here. Instead, microbes might rely on different pigments to harvest energy and protect themselves from intense ultraviolet radiation. And those pigments? They'd likely appear purple or dark purple. As Kaltenegger puts it, the redder the light gets, the darker the organisms would become. Her team has already built a catalog of Earth microbes with various pigments that could serve as models for what alien life might look like under different conditions. It's a massive shift in thinking. We're no longer just looking for another Earth. We're looking for life that adapted to its own unique environment. But color alone won't seal the deal. That's where atmospheric analysis comes in. Thanks to the James Webb Space Telescope, scientists can now examine what exoplanet atmospheres are made of by studying how starlight filters through them. They're hunting for biosignature gases, chemicals like oxygen, methane, dimethyl sulfide, and phosphine that could signal biological activity. The trick is that no single gas is a smoking gun. Oxygen, for example, can be produced without any life involved. What really gets researchers excited is finding specific combinations of gases that shouldn't coexist unless something living is replenishing them. Methane and oxygen together on a rocky planet in a star's habitable zone? That would be a massive deal. And we've already learned how tricky this kind of detective work can be. A few years ago, scientists announced they detected phosphine in the clouds of Venus, which briefly set the science world on fire. Further analysis suggested it was probably sulfur dioxide instead, a false alarm from the planet right next door. Now imagine doing that same work on a world hundreds of light years away. That's why upcoming tools are so important. The extremely large telescope, currently under construction in Chile's Atacama Desert, is expected to see first light around 2028 or 2029. Its 39-meter primary mirror will gather 250 times more light than Hubble and produce images 15 times sharper. Meanwhile, NASA's planned Habitable Worlds Observatory, targeted for the 2040s, would be the first space telescope specifically designed to directly image Earth-sized planets around Sun-like stars and scan their atmospheres for signs of life. And there's one more angle that might surprise you. Instead of hunting for microbes, some researchers at the SETI Institute are looking for signs of technology, things like industrial pollutant gases, artificial lighting patterns, or even massive structures in space. The logic is that while intelligent civilizations may be rarer than microbial life, their technological fingerprints could persist long after the civilization itself is gone. Projects like Laser SETI are already scanning the sky for laser signals that could indicate an advanced civilization somewhere out there. We are building the tools. We are refining the methods. And the next generation of telescopes will give us a view of distant worlds that was pure science fiction just 20 years ago. If you want to stay in the loop as these discoveries unfold, hit subscribe and turn on notifications, because the answer to whether we're alone might come sooner than any of us expect.